CRAM, an advanced automated point defense Gatling gun. Indirect fire from mortars, missiles, and artillery shells is a very serious concern for armed forces in a battle.
At sea, it is designed to defeat anti-ship missiles and close-in threats that have pierced other lines of defense. On land, as part of the U.S. Army's counter-rocket, artillery, and mortar systems, it detects and destroys incoming rounds. It also helps provide early warnings of attacks. The Phalanx Close-In Weapon System, or C.I.W.S., is an aerial weapon engineered to use a high rate of fire and ammunition to blanket a given area, destroying or knocking enemy fire out of the sky before it can reach a ship. The Phalanx C.I.W.S., which can fire up to 4,500 rounds per minute, has been protecting ship platforms for decades. A self-contained package, the Phalanx weapon system automatically carries out functions usually performed by multiple systems: search, detection, threat evaluation, tracking, engagement, and kill assessment. The Block 1B version of the system adds control stations that allow operators to visually track and identify targets before engagement. The Phalanx has had several versions throughout its career. Block 1B Phalanx Surface Mode, PSUM. The 1B variant's configuration augments the Phalanx system's proven anti-air warfare capability by adding a forward-looking infrared sensor. It allows the system to be used against helicopters and high-speed surface craft at sea, while the land-based version helps identify and confirm incoming dangers. The Phalanx weapon system is installed on all U.S. Navy surface combatant ship classes and on those of 24 allied nations. The land-based version is forward deployed and has been used in combat. The Phalanx is a necessity for U.S. naval ships to enter disputed seas, or seas with a U.S. adversary conducting anti-access aerial denial A2/AD operations within the territory. Anti-access aerial denial is an increasing issue in areas such as the South China Sea and the Baltic territories. Without systems such as the Phalanx, U.S. naval vessels would be vulnerable to cruise missile, ballistic missiles, or aerial attacks. Having the capability to shoot down incoming threats can give U.S. sailors confidence to maintain the balance of power on the sea. The upgrades are designed to substantially increase capability and ensure that the system remains viable in the face of a fast-changing and increasingly complex threat environment. The C.I.W.S. is designed to be the last line of defense against anti-ship missiles. Due to its design criteria, its effective range is very short relative to the range of modern ASMs, from 1 to 5 nautical miles, 2 to 9 kilometers. The gun mount moves at a very high speed and with great precision. The system takes minimal inputs from the ship, making it capable of functioning despite potential damage to the ship. The only inputs required for operation are 440-volt AC 3-phase electric power at 60 Hz and water for electronics cooling. For full operation, including some non-essential functions, it also has inputs for ship's true compass heading and 115-volt AC for the pass subsystem. The C.I.W.S. has 2 antennas that work together to engage targets. The first antenna, for searching, is located inside the radome on the weapon control group, top of the white painted portion. The search subsystem provides bearing, range, velocity, heading, and altitude information of potential targets to the C.I.W.S. computer. This information is analyzed to determine whether the detected object should be engaged by the C.I.W.S. system. Once the computer identifies a valid target, the mount moves to face the target and then hands the target over to the tracking antenna. The track antenna is extremely precise, but views a much smaller area. The tracking subsystem observes the target until the computer determines that the probability of a successful hit is maximized, and then, depending on the operator conditions, the system either fires automatically or recommends fire to the operator. While firing, the system tracks outgoing rounds and walks them onto the target. Centurion, CRAM. Seeking a solution to continual rocket and mortar attacks, the U.S. Army requested a quick-to-field anti-projectile system as part of its counter-rocket artillery mortar initiative. The end result of this program was the Centurion. For all intents and purposes, a terrestrial version of the Navy's C.I.W.S. Each system consists of a modified Phalanx 1B C.I.W.S, powered by an attached generator and mounted on a trailer for mobility. Including the same 20mm M61A1 Gatling gun, the unit is likewise capable of firing 4,500 20mm rounds per minute. Like the naval version, Centurion uses Ku-band radar and FLIR to detect and track incoming projectiles, and is also capable of engaging surface targets, with the system able to reach a -25-degree elevation. The Centurion is reportedly capable of defending a 0.5 square mile, 1.3 kilometers squared area. One major difference between the land and sea-based variants is the choice of ammunition. Whereas naval Phalanx systems fire tungsten armor-piercing rounds, the CRAM uses the 20mm HEIT-SD, high-explosive incendiary tracer self-destruct ammunition, originally developed for the M163 Vulcan air defense system. These rounds explode on impact with the target, or on tracer burnout, thereby greatly reducing the risk of collateral damage from rounds that fail to hit their target.